I trust that you recognize this as a quadratic equation. Quadratic equations are equations in which the highest power of the variable in the equation is the second power. You probably have learned a method for solving quadratic equations that involve factoring. Taking the polynomial, whether it's a trinomial as we have here, perhaps a binomial, sometimes even four-termed polynomials, factoring the polynomial and then applying the zero product property to be able to find the solutions to this equation. And there are typically two solutions to a quadratic equation. The degree of the equation indicates the maximum number of solutions we would typically have. So if we approached this quadratic equation the way you have probably learned, through factoring, the equation's in standard form, and that's the form we want it in when we're going to try to factor that trinomial to solve the equation. So we'd look at the trinomial and see if we can factor it into two binomials. There's no common factor that I can take out. So I'm just going to factor that trinomial. It's going to factor into two binomials if it's factorable. These are both additions, so the binomials will both be additions. How can I make x squared? Well, the only pair that we're interested in would be x times x. So those terms would go into the first positions of the binomials. And then we consider how we can make a 24, which would be the L of FOIL, would make our 24 for us. Well, that could be 1 and 24, 2 and 12, 3 and 8, 4 and 6 are all possible pairs that could go into those positions. And I can see that one of them I could use to make an 11. That would be the 3 and the 8. And so we can solve this equation with our factoring approach, as we've done before. The product of these two quantities is supposed to be 0. Well, that can only happen if this one is 0 or this one is 0, correct? Isn't that the only way to get 0 for a product, is one of those factors has to be 0? So then I simply ask myself the question, if this quantity was the quantity that became 0 because of the value I put in for x to make it 0, what value of x would that have to have been? Well, it would have had to have been -3. -3 plus 3 would make this 0, and 0 times anything equals 0. So now the left side is 0 as the right side is, which tells me that when x was -3, I have a solution. So there's one of my solutions to this quadratic equation. Well, if this wasn't the quantity that became 0 for the whole product to be 0, it would have had to have been this quantity that became 0. And the value of x that would make this quantity 0 is -8. And we have our two solutions to that quadratic equation. Well, that works beautifully if the polynomial we have is factorable. But if the polynomial we have is not factorable, is there some other method that we can use to find a solution to this quadratic equation? And the answer is yes. I probably wouldn't have asked the question if the answer wasn't yes. And that's what we want to look at next. So in the next video, you will be presented with a method that we can use to solve any quadratic equation, even quadratic equations where the polynomial was factorable, but especially those where it wasn't. And that method that we have is what is called the quadratic formula. And so in the next video, and several videos after that, I'll be demonstrating for you the use of the quadratic formula for solving quadratic equations when the polynomial is not factorable.